Hello, I'm very happy to be part of you today throughout this video. Likely the technology facilitates all communication. What I am going to present to you is a work that is very important to me. So I can start by introducing myself. My name is Hajjajib Ouahabi. I work in the laboratory of Condensed Matter and Radiation Faculty of Sciences, Tetouan, Morocco. What I want to present now is an experimental study about application of the turbulence models at low Reynolds number for horizontal axis wind turbine design by using computational fluid dynamic CFD. Here is the following plan. I will start with the introduction, secondly objective, thirdly methodology, then general remarks covering equations, hypothetical model for turbulence simulation, results and discussion, and finally the conclusion. Introduction. Nowadays, the upwind three-bladed horizontal axis wind turbine is the leading player on the market. It has been found to be the best industrial compromise in the range of different turbine construction. The current wind industry innovation is conducted in the development of individual turbine components. The blade geometry, namely the chord, twists, and airfoil type distribution along the span, responds to the output measures of the blade performance. Therefore, the optimal wind blade geometry can improve the overall turbine performance. Objective. The objective of this paper is to find chord and twist distribution for wind turbine design. The design process includes the selection of the wind turbine type and the determination of the blade airfoil, twist angle and chord length distribution along the radius. They are optimized based on conservation of angular momentum and theory of aerodynamic forces on an airfoil. Blade element momentum beam is the first derived, then used to conduct a parametric study that will determine if the optimized value of blade twist and chord length create the most efficient blade geometry. Finally, two different airfoils are analyzed to determine which one create the most efficient wind turbine blade by using computational fluid dynamic tool CFD. Well, the methodology. In this study, two-dimensional models of airfoil NACA 0012 and NACA 2412 are analyzed for the aerodynamic characteristics at various Reynolds numbers for a range of angles of attack from low left shroud stall, based on the chord length of the airfoil, the local characteristics, the lift, drag, pressure coefficients are simulated by using three models, the Spallart-Almaraz, the K-epsilon RNG, and the K-omega shear stress transfer SST. The comparison of production and experimental measurements in the wind tunnel of the National Aeronautics Advisory Committee NACA for selected aerodynamic parameters result at the specific Reynolds numbers. Then, the general remarks. The question, what is the flow turbulent? Flows can be characterized by the Reynolds numbers. For external flows, the common criteria are based on the Reynolds numbers where the length scale varies with the flow rate. Here is a picture that illustrates the kinds of flow. Laminar for low Reynolds number, transition increasing Reynolds number, and the turbulent higher Reynolds number. The second shows the turbulent flow structure, the small and the large. Energy is transferred from large vortices to smaller vortices. In the smallest vortices, the turbulent energy is converted into internal energy by viscodissipation. The governing equations are the basic equations that are solved for fluid flow problems, which are written as follows. The first term is local acceleration, the second convection, the third piezometric pressure gradient, and the last is the physical term. There is the continuity equation and equation of state. Hypothetical models for turbulence simulation. I used in the present work 3 models of turbulence, namely Spalart-Almaraz, the gamma epsilon RNG, and gamma omega SST turbulence model. All of these models are popular and are applied for low Reynolds number. Then on this fluent, this picture shown some steps in order to get the obtained result throughout on this workbench. Also, how to create geometry using ANSYS design modeler. The weight and the length of the blades are a function of the desired aerodynamic performance and the maximum desired rotor power. Then, how to create mesh by using ANSYS mesh. Finally, set up and solve problem and analyze result using ANSYS Fluent. Result and discussion. The study was conducted using ANSYS Fluent simulation software for NACA 0012 and NACA 2412 airfoil. The numerical calculations were carried out at different angles of attack. The objective of this calculation is to find optimum angle of attack to obtain maximum lift to drag ratio. Also, the pressure coefficient formed around of 2 airfoils were calculated and compared with different angles of attack of airfoil. Table 1 showed the computational condition, while lift and the drag coefficient for different angles of attack were calculated and shown in figure 1 and 2. These figures illustrate chord length and twist distribution as function for both NACA 0012 and NACA 2412 radius in order to know the ideal geometry for a turbine blade. Figures 7 and 8 give the comparison of pressure distribution over the surface of both NACA airfoil between angle of attack between -4 to 4 for Reynolds number equal 1 million. As can be seen from this figure, with the decreasing the angle of attack from 0 to -4 degree, the pressure difference upper and lower surface decreases. After 0 degree, with increasing of the angle, the pressure difference between upper and lower surface starts to increase. Again, around 4 degree, the pressure difference between upper and lower surface reaches the maximum. Conclusion. This paper numerically investigates optimum angle of attack for 2 airfoils, NACA 0012 and NACA 2412, to find maximum lift and drag ratio for Reynolds number equal 1 million. The study simulates airflow around airfoils using 3 models of turbulence, namely Spalart-Almaraz, gamma omega SST, and gamma epsilon RNG. Initially, airfoils are simulated and the results were compared. Lift, drag, pressure coefficient, lift to drag ratio, power output for the airfoils, chord and twist distribution were calculated. From the obtained results, all three models had a good agreement with the experimental from angle of attack between -4 to 4. Based BAM theory was confirmed that changing the airfoils could have an appreciable effect on the turbine efficiency. In the comparison between the two airfoils, it is clear that the NACA 2412 creates a more efficient turbulent blade than the NACA 0012. Thank you for your attention.